So let's take a look at advanced improper integrals. So looking at the problem of the integral from negative infinity to infinity of 6x cubed over x to the 4 plus 1 squared, notice how we have negative infinity on the bottom bound and infinity on the top bound. And this basically makes the integral double improper. And so it requires a little bit of extra work to solve. So the very first thing we have to do when there's a negative infinity and an infinity is we have to split them up. So I can rewrite this as the integral. So I'm going to take the bottom bound and put it on the bottom of the new integral. And then I'll put 0. Because we know 0 is between negative infinity and infinity. So I just put that at the top bound of the same function, 6x cubed over x to the 4th plus 1 squared, plus the integral. Now I can put 0 on the bottom. So we go from 0 to the top bound, which is infinity. So plus the integral from 0 to infinity of, once again, that same function, 6x cubed over x to the 4th plus 1 squared dx. And now the next step is to set up limits. So we have to set up a limit for both of these integrals because they're both improper since they have infinity or negative infinity as one of their bounds. So we can rewrite it as the limit, and you can use any letter but except for x because x is already in the function. So I'll just write b, the limit as b approaches negative infinity for my first integral of the integral. And once again, since I said as b approaches negative infinity, I can replace negative infinity with b. So we go from b to 0, once again the same function. And then plus another limit. I can use the same letter, this time as b approaches infinity, because that's my upper bound of the integral from 0 to b. Once again, I replaced it of the function 6x cubed over x to the 4 plus 1 squared. So now we can go ahead and solve, and I'll just start by solving this limit first, and then I'll move on to the other limit. So if we were to integrate 6x cubed over x to the 4 plus 1 squared, we can just use simple u substitution. So if u is equal to x to the 4th plus 1, then du will be 4x cubed dx, which would make dx equal to du over 4x cubed. So then when I plug it into my integral, or when I substitute du over 4x cubed for dx, and I do u substitution, we get 6x cubed over x to the 4th plus 1 is equal to u, so I can substitute that for u. So we get u squared times dx, and dx is equal to du over 4x cubed. So notice how the x cubes will cancel, and we have 6 over 4. We can actually take that outside the integral and simplify that to 3 halves. So we can write 3 halves times the integral from b to 0 of 1 over u squared du. And I can actually rewrite u squared as u to the negative second power. So now I can use the power rule, where we get 3 halves times u to the negative first over negative 1. So then we get 3 halves, or negative 3 halves, because of that negative 1. Then we get u to the negative first, which means I can just move the u to the denominator. And remember that u is equal to x to the 4th plus 1, so I can write x to the 4th plus 1. And so our integral, or the answer for the integral, is negative 3 over 2 times x to the 4th plus 1. So now that we have found the answer to the integral of 6x cubed over x to the 4 plus 1 squared, we can rewrite our limit notation. So we have the limit as b approaches infinity or negative infinity, of negative 3 over 2 times x to the 4th plus 1. And remember, the integral was from b to 0, so we have to put in our bounds because we're going from b to 0. So first I can plug in 0 for x, and when I do so, I'll get negative 3 over 2 times x to the 4th, or 0 to the 4th plus 1, which is 1, minus, when I plug in b to the equation, and I'll get negative 3 over 2 times b to the 4th plus 1. And so when I simplify this, negative 3 over 2 times 1 is negative 3 halves. And we have a minus and negative, so I can just make that a plus sign. So plus 3 over 2 times b to the 4th plus 1. And once again, I can rewrite the limit notation. So the limit as b approaches negative infinity of negative 3 halves plus 3 over 2 times b to the 4th plus 1. And now I can substitute infinity in for b, or negative infinity. So I'll get negative 3 halves plus 3 over 2 times negative infinity to the 4th power plus 1. Negative infinity to the 4th power is infinity, and infinity plus 1 is infinity, and infinity times 2 once again is infinity. And so 3 over infinity, so we get negative 3 halves plus 3 over infinity. Since infinity is such a large number, we'll basically make it 0. So negative 3 halves plus 0 is just going to equal negative 3 halves. And negative 3 halves, remember, is the limit as b approaches infinity of this integral. Now we still have to find this integral now, but this process is made much easier because we've already found the integral of 6x cubed over x to the 4 plus 1 squared. So I'm just going to label this section because we already know this limit is equal to negative 3 halves. And now we just need to find this limit on the right. And so we already know the integral of 6x cubed over x to the 4th plus 1 squared is equal to negative 3 over 2 times x to the 4th plus 1. So we can just rewrite it and then once again insert our bounds. From 0 to b. So we can write negative 3 over 2 times x to the 4th plus 1. And once again, we're going from 0 to b this time. And it's the limit as b approaches infinity. So if I were to evaluate this really quickly, when I plug in b, I'll get negative 3 over 2 times b to the 4th plus 1, minus when I plug in 0, I'll get negative 3 over 2 times 0 to the 4th power, which is 0 plus 1, which is 1. Then we get negative 3 over 2 times b to the 4th plus 1. Since there's a negative and a negative, I can make that a positive. So we get plus 3 over 2 times 1, which is 2. So we get 3 halves. So once again, I can rewrite the limit as b approaches infinity. So we have the limit as b approaches infinity of what we found here. So we have negative 3 over 2 times b to the 4th plus 1 plus 3 halves. And now all I have left to do is substitute b, or substitute infinity for b. So when I plug in infinity, I'll get negative 3 over 2 times infinity to the 4th plus 1 plus 3 halves. So infinity to the 4th is infinity. Infinity plus 1 is infinity, times 2 is still infinity. So we get negative 3 over infinity plus 3 halves. Negative 3 over infinity is basically 0, and 0 plus 3 halves is 3 halves. So now I can go back up here and say that this part, or this limit, is equal to 3 halves. And since there's a plus sign here, all I have to do is add these two, and negative 3 halves plus 3 halves gives us the final answer of 0. So this entire limit from negative infinity to infinity, or the integral of 6x cubed over x to the 4 plus 1 squared, will converge to the value of 0.